Um, Next here we will explain what arrangement of what resistor in a circuit. So that is our next subtopic under this topic, which is what arrangement of what resistors. Now in a circuit we have basically three ways to arrange resistors. We have the first one, we have the series arrangement. We have the series arrangement. We have the what the parallel arrangement. We have the what parallel arrangement. And the third one, we have the what combination. The combination, which is of what series and what parallel. So we have the series arrangement, we have the parallel arrangement, then we have the what the combination of what both series and parallel. So these are the three ways we can do what arrange resistor in a circuit. So I will pick them one by one and explain. So the first one here I'm picking will be what the series arrangement. The series arrangement. Now in series arrangement, the resistors are arranged on a straight line such a way that the same current flows through it. Don't forget that in series arrangement the same current flows through it. So because we have the same current flowing through it, the voltage drop will be dependent on the what resistor. That means the value of what resistor. So we will not have equal voltage drop, equal potential difference at each resistor unit. So take note that we are not going to have equal voltage drop due to what different in what resistance. Don't forget series, you have what the same current flows through it. So in series arrangement we should take that we have four resistors R1, R2, R3, R4. We have four resistors in series from a source, say a cell. So we have this cell supplying current through these four resistors. Let's also assume that R1 is not equal to R2 and it's not equal to R3 and it's not equal to R4. That means that if none of these happen to be equal, the voltage drop at each of these points would be what would be different. So which is why we say that in series arrangement the same current passes through it, but what different voltage. Don't forget that. So since we have the same current flowing through it, the voltage drop at this point, let's call it V1. The voltage drop at this point, let's call it V2. The voltage drop at this point, let's call it V3, and the voltage drop at this point, let's call it V4. So from here, the total voltage drop will do what? Give us what? The total voltage supply. That means our total voltage supply V will be equal to what? V1 plus V2 plus V3 plus V4. What are we going to have as our voltage drop at V1? Don't forget that the source, the current, we should term it I, flows through this. So at V1, we have what? The current times our R1. At V2, we have the same current times the R2. At V3, we have the same current times R3. And at V4, we have the same current times R4. So if we substitute this here, substitute this into this, that means we have our V will be equal to what? V1, which is IR1, plus V2, IR2, plus V3, IR3, plus V4, IR4. So since we have current as the common item, so we take current out. So we have what? R1 plus R2 plus R3 plus R4. Don't forget that this voltage source is given as what? This V equals to what? IR, where the R is what? The total resistance. So from here If we simplify, this I will cancel this I. That means our total resistance in this circuit is the sum of what individual resistance. So we have this as the formula. So whenever you are looking for the net resistance in series arrangement, all you need to do is do what? Sum the what? Individual resistance. The total will now give you the net resistance in that circuit in series arrangement. Now let's see how to solve simple question with this. Okay, let's see how to solve simple series connection. We have a very fine question on the board. Let's see how we can go about that. From the circuit above, that is this circuit, from this circuit we have 5 ohms, 2 ohms and 3 ohms resistors, all connected in what? Series, with what? A 20 volt supply from a cell. So from the circuit above, find V1, V2, V3. That means voltage will drop at 5 ohms, voltage drop at 2 ohms, and voltage drop at what? 3 ohms. So let's see how to go about that. So from here we have our R1 to be 5 ohms, our R2 to be 2 ohms, and we have our R3 to be 3 ohms. Don't forget what I told you earlier, that our total R, which is the net R, or the resultant R, is given as what? R1 plus R2 plus R3, just the sum of this. So just add, finish. That means 5 plus 2 plus 3, all in what? In ohms. So 5 plus 2 plus 3 gives us what? 10 ohms. So our R is what? 10 ohms. Our total R is 10 ohms. And our voltage source V was what? 20 volts. So what are we missing here? We are looking for the what? The current flow. So the use the formula V equals to what? I times R. So we have our I will give us V over R. That means what? 20 over 10. So the current flow will be what? 2 ampere. So the current flow through the circuit is what? 2 ampere. Don't forget, we were not asked to find current flow. We were asked to find the potential drop. But we look for current flow because it will help us find potential drop with ease. Because I told you earlier that the same current will flow through the circuit, but different what? Voltage drop at each point. So now that we know the current that flows through the circuit, let's find the potential drop. So at point V1, at V1 we have what? R times R1. Our I at that point will be what? 2 times our R will be what? 5. So 2 times 5 will give us what? 10 volts. So 10 volts is your what? Your potential drop at 5 ohms. Let's advance. So for your V2, that means what? I times what? R2. Your I is what? 2 times your R2 is what? 2. So 2 times 2 will give you what? 4 volts. So at this point we have 4 volts. And V3 will be what? I times R3. The same thing, I is still what? 2. And you have what? 3. 3 times 2 give us what? 6 volts. Now let's do a rough check if we are correct. I told you earlier that the sum of voltage drop at each point will now give you what? The total voltage supply. So let's see. If we sum this, 10 plus 4 plus 6, you have what? 20. That is just a rough check to check if you are correct. I hope you understand this example. Okay, example 2. We have 3 resistors, 5 ohms, 8 ohms and 7 ohms are connected in series. If the voltage drop at 7 ohms is 17.5 volts, calculate the source voltage in the circuit. That means from the question we are asked to find the total voltage in the circuit. You can solve this without actually having to sketch, but I always encourage when you sketch, it shows that you actually understand what you're doing. So first, let's have a sketch of this circuit. So this circuit, we have 3 resistors in series. So we have 3 resistors in series to a source, which could be a battery. Then we have 5 ohms, 8 ohms, and 7 ohms. And we are told that the voltage drop at 7 ohms. That means the voltage drop at this point. The voltage drop at 7 ohms is what? 17.5 volts. So the voltage drop at 7 ohms is 17.5. You are asked to find your V. So from here, what do we have? Let's see. We have our R. Our total R, like in the previous example, would be what? The sum of all this R. That means 5 plus 8 plus 7. So that will give us what? 20 ohms as our total R. Then what next are we going to do? We are looking for V. Do we know I? Our total I is not known, but we have in mind that the same current will flow through this circuit. That means the current that flows through here that dropped this 17.5 volts must be the same current that flows through the circuit. So let's find the current at this point and use it across here. So the current at this point will be what? So I'm looking at 7 ohm resistor. So at 7 ohms resistor, my V equals to what? IR. So my V at 7 ohms is what? 17.5. And my I is what? Unknown. And my R at 7 ohms is what? 7. So that means 7I equals to 17.5. So my I, the current would be what? 17.5 divided by 7. What would that give me? 7 in 17.5 should be 2.5 ampere. So now I know my current. Wow. Once current is known, what do I need? I'm almost through with the work. So from here, for me to find my supply voltage, I will use my supply voltage to be what? The total current that flows through the circuit, which is 2.5, and my what? Total resistance. So from here, I have that my V equals to my I is what? 2.5 times my R. My R is what? 20. So when I times this together, I will have what? 50 volts. So my supply voltage is what? 50 volts. I hope this is clear. This is just you playing around your mathematics.